So a PLA, programmable logic array, is an old device that people would use to, it's got a decoder on the front end, and it's got transistors set up so that you can store these bits, and you have 2 to the m bits that you can store to specify a given function. So you've got a little chip where you say, well, I can put some bits into it to specify a function, and then out on my wire comes that function. And any function you want, okay, on these n bits. So it's not just one. Typically, they would give you, some number of functions you could specify, and you could set them up any way you wanted. Each of these lines is a function. So this is the array part, right? So there's not only one column, but there's multiple columns. Each column is a function. Each of these rows is a min-term of the input. And you put your x's wherever you want. Each of those x's is 1 bit. And you could specify different functions that way by storing the min-term representation, the canonical SOP form. Okay? So that was the programmable logic array. When it was in use, it was before people had, people were still using physical small chips, but those chips would typically have things like a few gates on them, right? And so this was a fairly powerful abstraction for starting to integrate circuits and have more than just a few gates on one chip. You started being able to do arbitrary functions regardless, dynamically. I could just buy one chip and put some functions into it. It's a lot more powerful than having to buy a bunch of chips and or not gates and wire them up. So this was a pretty big advance, but it was a long time ago. Now what people are doing is using field programmable gate arrays. There are structures like this in them for connecting horizontal and vertical wires and making those kind of connections and doing routing on the FPGA. But there are also more sophisticated structures like lookup tables, random access memories sitting on it. A lot of them now actually have microprocessors embedded into the FPGA fabric. Right? They were doing that a decade ago. It didn't work out for them. I mean, my research group used them in 2004 timeframe. But then they sort of went away for a while, but now they're back again. Okay? They've always had what are called soft cores, where you can design microprocessors, put them onto the FPGA fabric, and have them execute. But now they've also got physically processor cores built into the FPGA fabric and connected to it, so you can have Linux running on the FPGA connecting to the dynamically designed hardware. Right? So there's a lot of flexibility in this platform. So there's some interesting stuff there. This is kind of the key concept that you can build logic that is controlled by memory. And we haven't talked about how to build memory yet in this class. I know you've seen some of it in 190, how to build a bit. We'll go over that again next week.
Oh my God.